Hi and welcome. I'm trying to learn space science. Today, what happens if a meteorite collides with Earth? And after that, we're going to do stretching. And if you participate in the stretching, that is at your own risk. And I haven't let it, but it is about a disaster, probably. A possible disaster. Now, what happens if a meteorite collides with Earth? Now, a meteorite, that seems to be some type of rock, like that or that one. We haven't read it now, for now, so we don't know the difference of asteroids, meteorites, meteorites yet. But a meteorite is a piece of stone which could hit the Earth. Now, what happens if that happens? Meteorites collide with Earth millions of times every day. Now, it happens every day millions of times. When one enters Earth's atmosphere, it rubs against the air. This friction causes the rock to heat up. It becomes so hot that it glows. If you drive, or if you run fast, or if you drive with a bike, you can feel the pressure of the wind, or if it's windy, you can feel the wind. And that already, you can feel the air's pressure already. If there's a stronger wind, you can feel the strong force, and if you run faster. And now if you're very fast, like a meteorite coming with a rock, very, very, very fast, way faster than a car, this pressure is way stronger, not just as normal wind or very strong wind, but way faster. And this rubs against it, and this causes friction. And if friction happens, it causes heat. Right? No, and this heat is so strong that the thing starts to glow. The rock starts to glow and basically just evaporates away. I don't know what the correct term is, but the rock just goes away, basically. It glows. Oh, we're reading on, maybe they explain it better. These glowing space rocks are known as shooting stars, but scientists call them meteors. Okay, these are rocks, and they can be seen as shooting stars, but scientists call them meteors. Okay, these are the meteors. Most boil away to nothing, so they boil just away. They evaporate to nothing. But those that are larger than 30 kilograms, so half the weight of an adult human around, larger than 30 kilograms often make it to the ground. Then they are known as meteorites. Okay, if they're just 4 or 5 kilograms of a rock, a normal rock, then they just evaporate away because they are so fast traveling through the air, and all this air is like a strong wind pressing all against the rock at all sides. And that happens so wrong, so fast, with so much friction that the stone starts to glow and just evaporates away like water boils away. Then they just are away, and they are shooting stars or meteors. But if they are heavier than 30 kilograms, so quite heavy, then they hit the ground. And then they are called meteorites, because they are so big then, and then the friction is not sufficient. We had it here with the atmosphere in the previous part. Now, where does space start? They said the Cameron line, 100 kilometers. Now, the atmosphere is somewhere here with 100 kilometers, and space starts from here. So, as long as the meteorite is just here, there's no air and no friction happens. It just travels on. And as soon as it's there and hits the atmosphere, and here comes air, then the friction starts. Just in space, there is no air, and the rock just flies on forever. But when it hits the atmosphere at around, I don't know where the atmosphere starts, around 100 kilometers, 50 kilometers, and there starts to be the air at 10, 20, 30 kilometers. And then it causes friction, and the rock just glows away. But if the rock is larger than the size and has more than 30 kilograms, then that is not enough. Like you have a little pot of water, or a small pond, what is it called? A puddle. If it's a little puddle, it's away in 1-2 hours of sun shining. But if it's a big puddle, a lake, it takes multiple days until the puddle or the lake is dried out. Now, rocks with 30 kilograms hit the Earth, and they are called meteorites. The next part is called, could a meteorite land in my garden? And then also here, what if a large asteroid hit Earth? And here, how worried should we be? Now, if you want to hear about this question and the answers to them, let's actually read with one part here. Let's look what it is. Scientists track more than 1,700 large asteroids. They are bigger than 140 meters across and have orbits that come close to crossing Earth's orbit. There is a chance they could collide with Earth in the future, but it doesn't mean that they will. Okay, what we're basically saying is where scientists tracking 1,700 of these larger rocks, so even more than just 30 kilograms, larger rocks, multiple meters, hundreds of meters big. They're tracking them, looking where they are. 1,700 are we looking at. And we're looking and studying, do they might hit the Earth? Probably not. And there is a very small chance that such a rock hits the Earth, but it's unlikely that it will happen in the foreseeable future. There is a very, very small chance, but the question how worried should we be? Basically not at all. Now, what happens if a meteorite collides with Earth? Most of them just travel past. Now, if they're coming into the atmosphere, these meteorites, they are glow away. But if they're larger than 30 kilograms, they are called then meteorites, and they hit the Earth, but not so much happens by these 30 kilograms larger ones. They are just hitting the ground like a stone. The larger ones, there could something happen, but it's unlikely that will happen in the foreseeable future. So if you were here for space science, then you can go directly to the next video where we will talk on about asteroids and meteorites. We try to do the differences and also use more than to it, to our section. If you're here for space science, go directly to the next video. We will do now the stretching. Did I announce it? I think it did. So if you were here for space science, go directly on. If you're here for stretching, then stay here. But if you participate, it is at your own risk. Next, I'm trying to wide apart and the breathing in, lifting the arms up. And breathe out, go over to one side. And breathe in and open the rib cage. And again out into the middle. And again in. And out over to the other side. Breathe again in and open the rib cage. And out into the middle. And the arms down. And now the next exercise, now it's the correct drop. Same setup, we're breathing in. And out with one hand slides down the leg, and the other shoulder stays down. And again in. And out taking one arm over. And breathe in and out the rib cage. And out back into the middle. Again in. And out one hand slides down the leg, and the other shoulder stays down. Breathe again in. And out we're taking one arm over. Breathe in and out the rib cage. And again out. Now the legs stand together, we're breathing in and lifting the arms up. And breathe out, we're letting one arm down the aeronautic, aerobatic, airplane. Breathe in and reach. And again out. And again in. And out, we're letting one hand down. Breathe in and reach. And out. The legs again shoulder wide apart. And we're doing forward shoulder circles. We're going back, up, and front, and down, and back, up, and front, and down. And now backwards and front, up, back, and down, again and front, up, back, and down. Now breathe in and lift the shoulders up. And out, let the shoulders fall down. And again in. And out, let them fall down. And again in. And out, letting them fall down. Now, yes, we're doing the upper plugger. Breathe in, lift the arms up. And just keep normal breathing. When you reach, always one at a time with the hands high up. You'll pretend to take an apple hanging high on an apple branch, turn it a bit around, and then to wrap it out. And the last two. And we're going on with a shifter. Next one part, arms up to a T, we're breathing in. And out, we're shifting just with the upper part of the body over to one side. Breathing in into the middle. And out over to the other side. Breathing in. And out, we're leaning onto our knees, the buffalo fighting its hangover exercise. We're breathing in. And out, we're bringing one shoulder in front. Again, in, one shoulder back. And out, one shoulder in front. Again, in and back. And out, one shoulder in front. In the shoulder back. And out the other one in front. Back in. And out, and we're doing the Niagara Falls. Just hanging down. We only have to come deeper down by breathing deep in through the nose into the chest. And by breathing out through the mouth. Again in. And out. Again. And now out, and we come over to one leg. Raise again in. And out. Again in. And out over to the other leg. Breathe again in. And out we go into the middle. And we're doing a style to angelo. We're bringing feet together, but we keep on hanging down. So breathe again in. And out. Again in. And out. And again in. And now out, we're coming slowly up with the round back, and making it a top to backwards, shoulder. Now we're doing the garland pose. The toes are pointing to the outside. We're having an ulnar lift space between the heels. We're breathing in, lifting the arms up. And we're breathing out, and we're sinking down, and we're placing the elbows against the inside of the knees. And now breathe in and straighten up the back. And breathe out and come with the back up. Breathe again in. And out. Again down. And breathe in and straighten up the back. And out. Again up. Breathe again in. Then out again down. We're going to straighten up the back. And out we're coming in a straight line, slowly upwards. There we go. So, and we're doing opposite pose. We're closing just legs wide apart. We're breathing in. And breathe out. Draw the shoulder blades together. Again in. And out. Again in. And out. Again in. Out. And up in and close the legs. Out. That was the stretching. I thank you very much, and until next time.